How vibration sensitive are hard disk drives? I've got my hands on a seriously cheap laptop grade 2.5-inch drive. I'm intending to use one on a desktop that doesn't have 2.5-inch bays as a boot drive. While I know there are adapters available, I know it's fairly common with SSDs to simply velcro/tape the drive somewhere. I'm wondering if I can do the same with a laptop hard drive. One issue I see here is SSDs are fairly insensitive to vibration, while hard drives are. Just how vibration sensitive are drives? Would a jerry-rigged mount need to take this into account?
Laptop drives are generally more vibration resistant than desktop drives. They are designed to be used in a moving plane, car, in a laptop on someone's laps, etc. So from this standpoint there shouldn't be a problem taping them somewhere inside your computer's case. There are other problems, however. When hard drive is fastened properly, metal bracket also acts as a heatsink. Moreover, in a properly designed case there should be an airflow around a hard drive. Your tape will have lower thermal conductivity than metal, and depending where you tape it, there could be less airflow available. So your hard drive could overheat. Constant vibration, from hard drive's motor, computers, fans, etc., can loosen the tape over time, depending what kind of a tape you use. It can dry up, etc. So don't put your hard drive vertically somewhere. Make sure it's fairly secure without the tape, and use the tape as an additional measure, not as something that prevents your hard drive from falling down on your motherboard, for example. Make sure you don't short anything on hard drive's PCB. If it is exposed, for example, there are no protruding screw heads on the surface that you tape your hard drive to. I've used tape to secure 2.5 inches hard drives in a desktop tapes, but only temporarily, till I got around to order a few of those conversion brackets.
The hard drive is not particularly sensitive to vibration. Vibration will destroy any piece of electronics over time, but drives produce their own vibration and hence are beefed up a bit. And laptop drives even more. The real limit with hard drives is peak G-force. This isn't vibration so much as shock, a sudden jolt, and it only takes one such event in excess of the drive's G-limit to damage a drive. A bit of a war story. Some years back, when I was working on IBM S/400 computers, they were having trouble in the development lab with drives failing. To permit multiple people to, serially, use a single test system, drives were mounted in sliding plug-in trays, and drives would be exchanged when a test scenario was changed. But it seems that drives would fail when exchanged this way. A drive would be good, would be carefully removed and gently set down on a conductive foam pad. But then, an hour later, the drive would be inserted and would be found to be crashed. Analysis of the drives showed that they'd been subjected to excessive shock, but originally no one could figure out the source of the shock. Then it was realized that the shock of snapping the drive into the socket, as the tray was slid into the machine, was enough to do this damage. Of course, these were old big iron drives, and current desktop and, especially, laptop drives are much more robust, but still the hazard is mechanical shock that does not seem, to a human, to even be worth noticing, but which to a drive can be devastating, due to the proximity of the shock source to the fragile parts in the drive.
Just to give some intuition, it is often said that you should handle a hard drive like a raw egg, and the point is that you can take this literally. According to this article, a raw egg should be able to withstand about 20 grams without breaking. Most modern hard drives are able to withstand about 60 plus G while operating. So if the shock would not have damaged the shell of a raw egg, you should be on the safe side, even when the hard drive was working.
wersję wam w sposób podwyższany, plus consider subscribing.